Hey everyone, I'm Jack and I'm a quantitative developer here at QuantConnect. I'm going to be taking over for Jared to present Idea Streams, which is a weekly video series where we take ideas derived from current market conditions and try and implement a trading strategy on the QuantConnect platform. This week we're going to go over the differences between nowcasting and forecasting and how to implement nowcasting in QuantConnect. So nowcasting is not an entirely new idea, but we are taking our inspiration from a presentation given by Lopez de Prado. He observes that the main differences between forecasting and nowcasting is that forecasting relies on very structured data, time series data, fundamentals, corporate earnings, data that's widely available and is somewhat lagging. And so forecasting uses lagging indicators, statistical relationships, conventional time series data, things like that to make predictions about the future. But nowcasting uses more unstructured or semi-structured data to take direct measurements, to make short-range predictions, and this can give an advantage to traders or funds who are using nowcasting in times of crisis, which is typically when you see traditional forecasts break down or when they start to fail. An important part of nowcasting is to first identify a cause-effect mechanism. So in our example today, our cause-effect mechanism is that we think that positive news announcements for companies that are developing coronavirus vaccines or other medications will boost stock prices. It's a basic cause and effect mechanism, but now we want to develop an investment strategy that monetizes the mechanism. So for us, it's as simple as seeing if an announcement is made, then if it's positive news, we buy the stock, sell the stock after a couple days to capture our gains, profit. So that's step two. The third step of implementing a nowcasting strategy is that we want to evaluate the performance of our trading rules, assuming that all of our data is there, assuming that all of our data is perfect. So when we build a strategy, we're first going to test our basic theory. Do stock prices for biotech stocks with positive news mentions about their COVID-19 therapies, do they increase after the news announcements? If we can develop a viable strategy like that, even when introducing look-ahead bias, then we go back and we build the model that gives us that data that we need. So our first step here is to open up a new algorithm. So we have that, and just to make the coding process a little bit quicker, I am going to take some symbols from my own personal web searching of different biotech companies that were involved in either developing coronavirus vaccine or treatments to help patients, and we're going to call that tickers here. So we have a list of 12 stocks, and I'm also going to import a list of dates that we know positive news events happen for these stocks. Again, we're introducing look-ahead bias, but this is just to test our cause and effect theory. So we're trying to build a trading strategy, assuming that we have perfect data that would give us these dates. So we have our data. Now, we have our dates and our tickers. And now what we need to do is, since we're using the framework models, we're going to want to create a list of symbols, the QuantConnect symbol objects. So we'll go ahead and create that. So we're using the symbol.create method. So what we have to do is we have to pass it a ticker, pass it the security type. We're dealing with equities. And the market is the US equities market. So we're using list comprehension here. Actually, we're going to use dictionary comprehension and use the symbols as keys and the dates as values in our dictionary. That way we can access the dates that belong to a specific symbol and the timing of their news event. So the ticker, date, And here I am zipping the tickers and dates together. It basically just makes a couple lists iterable. So this will give us a dictionary of symbols and dates that events happened that we want to use later. So since we're using the framework models, we're going to go in. We want to use a manual selection model because we're creating a universe of our own selected symbols. So we don't want to use fundamental or anything like that. So what I'm going to do is take that right there. I copy and paste that here. But since our symbols is actually a dictionary, I'm going to use this built-in Python method here. And this just takes the keys from the symbol dictionary, which is our symbols, and creates a list of them, which is what we want. We want to pass a list of QuantConnect symbols. And we're going to set the universe resolution to daily. Our goal here is to place trades before the news events happened in order to capture that upward momentum. And so we're going to place market on open orders, just deal with daily data. It's pretty simple, easier for our algorithm here. And now we want to create an alpha model. And so right now I'll just add this as kind of a placeholder before I actually write the model. Get rid of that since we're dealing with the framework and we don't need that. Let's go into the documentation and see about alpha creation. So we've added our alpha model, and let me grab just kind of a basic constructor for an alpha model here. Copy and paste that. We don't need the commenting. And we called it Biotech News Alpha. And we also need an initialize method. So we're going to add that here. And we'll fill that out later, but right now we need to think about our portfolio construction. And since we're dealing with very few tickers and the dates are kind of spread out, we're going to use an equal weighting strategy. So that means if there's only one ticker being traded that day, we'll go full weight in that. If there's two, we'll split it equally. It's perfect for our algorithm here. So let's find portfolio construction in the docs. No, here we go. Equal weighting portfolio construction model. So we're going to set that. And then we are also going to set an immediate execution model because we want those trades executed immediately on market open or as soon as possible. We're not worried about standard deviation of prices or volume weighted average price, anything like that. So we're going to go with immediate. And so we have our basic, actually we can change the start date too, since we're only dealing with the time of coronavirus. We'll start with data starting March 1st, since all the events happen in March, April, or May. So we have our basic algorithm here, our algorithm structure. Now what we need to do is add the alpha model. So what we're going to do is we're actually going to pass our dictionary of symbols and dates into the alpha model so that we can access them in there later. So we'll create a class variable. Now usually you would want to deal with security changes in the onSecurities change method. It's really helpful, it's really powerful. It allows you to access securities that are added or dropped out of the universe when that occurs. But since we've already created the dictionary in the initialize method, we're just going to pass it into the alpha model, create a class variable like that, and not actually use the onSecurities change method today. Our basic trading strategy or trading logic is that we want to check to see if at the time that we emit insights or place trades, if we are one day before the event actually happened. So what we can do here is need to make sure that all the indentation is correct. So we can iterate over the symbol and dates in the dictionary just by doing this 8 times. And so now that we are accessing symbols and dates, we see that each date is a list. And that's because some symbols have multiple dates that the events happened. And so it's just easier to iterate over if even the single elements are considered a one element list. So we are going to have to iterate over date, which in our case, again, is a list, either one or more elements. So we'll do this for D and date. Now we can use the algorithm time property to check what time are we at, where are we at in the algorithm, and are we 1 day before the date, are we 2 days before, etc. And so what we're going to do is add in algorithm.time plus time delta 1. The default for time delta in Python is daily, so that's just adding 1 day. So now we're checking if the algorithm is 1 day behind the event date, then we want to emit an insight. Again, so we can place that market on open order, capture the momentum, and then hopefully make a profit. So we're going to add an insight. And before I do that, let's take a look at insights. So insights you've probably seen before. It's a prediction about where a stock price is going to go. It has all these different properties. And for us, the most important one is going to be the duration and the symbol. So we're going to emit one insight for each symbol that has an event at the time that we're specifying. We're going to give it a time duration of 1 day, thinking that the market captures the upward swing, maybe loses a little bit of momentum, and even can revert if there's too much market exuberance. So we're going to call the insight constructor. We're going to pass it the QuantConnect symbol, and we're going to tell it that we want a duration of 1 day, an insight type of price, so we're making a prediction about the insight price, and we're going to say that the insight is going up. And since we're using an equal weighting portfolio construction model, we don't need to specify the weight of the insight, so we're just going to leave it at that. And that is pretty much the full logic of our trading strategy. Remember, we're assuming the data is perfect, and so we're testing our cause and effect mechanism and the trading rules that we're building around that mechanism. So we're going to go ahead and click backtest. All right, so we have a strategy. This is great. We're placing orders and emitting insights at the time that we told the algorithm to. We're seeing it places some trades. Our average win is really high. And we're seeing orders buy market open, sell market open. Okay, so we have a strategy. And so clearly there is some merit to our cause and effect relationship. We show that if we assume we have the data that we need, that relationship holds and we can build a successful trading strategy on it. Now, what we're going to do is go into the research notebook here, and we're going to build a basic Tingo News web scraping. So Tingo News is an alternative data source that we offer, and it is a global news feed for US equities. And so it's what we call a linked data source. That means that you add Tingo data for a specific security, as opposed to treasury yield curves or trading economics, all of which stand on their own. Tingo News data is added for a symbol. And so we can look at the Tingo News. The data has a title, description, source information. So this is going to be all really valuable in us building our news scraper. So I've pre-populated the research, but essentially we're importing the Tingo data that we need. We are initializing an instance of QuantBook, which is essential for creating the symbols that we'll need for making history data calls. Really, it's the backbone of the research environment. We've copied and pasted our ticker list. So we have our symbols here. And Again, using list comprehension, we are adding each ticker and taking the symbol property so that we have a collection of QuantConnect symbols, not just ticker strings. You always want to deal with symbols because symbols do not suffer the same pitfalls of delistings or the ticker changing from one company to another. You can use them for history calls. They're good for indexing or using as keys to dictionaries in your algorithm. So when you can, use symbols. And similarly here, you'll see we iterate over the symbols we just created. And for each one, we're adding Tingo News. So we're linking Tingo News data to a symbol. And then we're also going to take the Tingo News symbol so that we can get history, so we can get historical data. So we'll run that. Here what we're doing is we're fetching price data for our equity symbols and Tingo News data for all of our Tingo News symbols. And again, since we're only dealing with the last couple of months, we're going to go from March 1st till now. And Tingo News is minute resolution, so be sure to specify that. So we'll run that, and while it's running, there's actually a preview that we have of what the Tingo News data looks like. And so in a history call, this is what you're going to get. You're going to get back a pandas data frame. We're indexing it by the first symbol we have, just to get an idea of what the data looks like. And you can see that there's a time property, article ID, description, which is the one we're going to be interested in because it contains the article contents. That's all the string information we're going to be looking at. And then there's information about source, tags. You can see global coronavirus, global health, security, article title. This can all be used effectively in more sophisticated news scraping, but right now we're just going to create a pretty simple basic model that will serve our needs. So since we're doing a string search, I am using the Python regex, and regex can get really complicated or you can keep it simple. We're going to keep it simple today. First step, we are building another dictionary, and the key to this dictionary are our QuantConnect symbols. So each symbol is going to have a list, and what this list is going to contain is it's going to contain date, time, instances when we find an article that matches or contains our search terms that we've deemed important. And so what we've done as well is we've defined those keywords. So we have FDA approval, FDA approved, start human trials, start clinical trials. All of these are groups of words that if they appear in an article, we would deem significant, newsworthy. These would prompt stock price movement. And so this is getting us that data that we assumed in our initial algorithm that we had. So we're iterating over the Tingo symbols and the QuantConnect symbols. And what we're going to do is we're going to extract the news for the Tingo symbol, and we're going to iterate over each row. So for each row, there's the index and then there's the row contents. We're going to access the row contents. Inside of each row, we need to check for all combinations of these keywords. So we're going to iterate again through keywords, and we're going to check for matches. So regex search looks for the keyword that we're using, and if it appears in descriptions, so in the row's description. And we're going to ignore case because that makes life simple and easy. And you can see we're iterating over all instances of our keywords. So if all of these terms show up, so if we see FDA and approved in a description, then we're going to consider it a match. If we see start, clinical, and trials, we're going to consider it a match. If it's a match, we're going to add that date element to the list for that symbol. So if symbol X finds a match, we're going to add that date to its list. And this gives us a mapping of symbols to dates that news events happened. So we can run that. And as you can see in the date index, there's a lot of not overlapping dates, but these are only an hour apart, 50 minutes apart. These are only 32 minutes apart. So it might match multiple times per day, but we're concerned right now with daily scale. So once this finds all of the matches, gets all of the data that we need, we're actually going to sort those dates and take only the unique values. So list set takes a list of items, gets all the unique ones, returns it as a list, and then we're sorting it low to high. And so this is going to be the result of our search here. So you can see that there's plenty of data. Now, we want to be able to use this in an alpha model, in an algorithm. So what we're going to do is we're going to copy a few of these key elements back into our original algorithm. And so I'm going to create a class variable here called keywords and do a little, deleting here. Clean that up for you. And since we're not introducing look-ahead bias anymore, we're going to delete the dates. We don't need those. And we don't need a dictionary of symbols anymore. We just need the symbols themselves. So we're going to change this from dictionary comprehension to just regular old list comprehension. And this should give us a list of symbols. And we don't need to do that anymore since it's now a list. And we can actually take this out because we do not need to pass it in manually anymore, and instead we can use the on securities changed. So for security in changes added securities, on securities changed is super helpful. It's a great method. You'll see any securities that are added or dropped, like I said, and this is where we can add or remove, in the case of a dynamic universe, Tingo data. So I forgot that we need to import our Tingo data here. And then for each security, we're going to use that symbol, and we're going to add the data. So we're adding Tingo news data, and we're adding it again for a specific equity symbol, since it's a linked data source. And then that will populate our dictionary list of symbols. Now, it's actually going to be easier for us to do something where we fetch the Tingo news data in one batch from the data slice rather than iterating through. So what we can do is assign a variable like this, do data.get, and then we pass it the object that we want it to get. So we want it to get all of the Tingo news. Now we can iterate over the Tingo news data we retrieved, and we can use it like that. So I'm going to comment that out for now. And now we need to import our code from the research environment into our alpha model. And so the key part of our code is this here, is we want to know, are our keywords in the description? And if so, we want to emit an insight. Okay, so I'm going to change that so we don't have overlap here. So I'm going to assign a local variable here, and we're going to get the Tingo data that is specific to this symbol. And so again, we can look back. Tingo has these properties that you'll see on in the data slice, and we're concerned with the description. So that's what we're going to use. So instead of that, we're going to do article.description. And we need to use self.keywords since it's a class variable. And instead of adding the data to a dictionary to store for later, we want to use it now. We want to use it real time. So we're going to create an insight if we do find a match. All right, so we have our insights. We have our basic web search scraping, article scraping. And by using the data.get method, we aren't worried about any missing data slices that might happen if we iterated over our symbols instead. So that looks pretty good to go. Hopefully there aren't any bugs, but I'm sure that there might be. So we're going to go ahead and backtest that. I forgot, in switching, we no longer need that in our initialization method because we are not using it anymore. Okay, one more error here. There's no attribute symbols. Of course, I still need this here. So we need to create it when we create our class so that we can access it down here later. And let's hope this is the last run. I have to make sure I have all my correct imports here. This is real live coding and you get to see all the bugs involved. Line 39, let's see. Right. So this is from our old code. So instead of sim, what we actually want to do is we need to emit an insight for the underlying equity. So Tingo actually has a good method for that. So in the Tingo data, you can see that you can get the Tingo symbol and then the underlying symbol. So that's the one that we want to emit an insight for. Okay. Now let's hope that this works this time. All right, we have a backtest. It ran. We see some profit. We see a great probabilistic Sharpe ratio. And we can see our statistics here. And so we have ourselves a strategy. So what we've done is, using Nowcasting, we've taken a cause and effect idea that we hypothesized. We tested it assuming that the data for that cause and effect was perfect. So we developed our trading strategy, and then we went back and we created a little model in the research environment to give us that data that we needed in order for our strategy to be effective. Turn that all into a new algorithm using the framework models, and we have a successful trading strategy. It's a very primitive implementation, but it is a good jumping off point for you guys to create your own web scraping data or news scraping data, or just to give you an idea of what Nowcasting is and how you might use Nowcasting in a different way. So with all that in mind, I hope you now have a better idea of how to approach Nowcasting using the QuantConnect platform and resources. If you would like clarification on any of these points or have general questions about our platform or processes, please don't hesitate to reach out. Both the QuantConnect team and the community of users, which is now over 100,000 strong, are valuable resources at your disposal. I'll see you next week. Until then, happy coding.